Who's hosting this show? Hi, this is Amy Lewis.
Or makeup.
This is Engineers Unplugged. Hi, this is Amy Lewis, and we're back for an incredible episode of Engineers Unplugged. We've got Jacoby, and we've got Nathan, and they're going to be talking about transactions. So, Nathan, take it away for us.
Thank you, Amy. Jacoby, welcome to Cisco Live. How's it been going for you?
So far it's been really interesting. We've met a lot of different people, and we're pushing the message that transactions are best expressed in the infrastructure rather than applications. And it's a difficult message to put across, but a lot of people are beginning to get it.
Transactions in the infrastructure itself. What exactly does that mean, Jacoby? Come on, tell me.
Well, the way we do transactions today is we have programmers write programs. And the difficulty with that is that the logic is hidden inside an opaque source file. Now, with a transaction router, which is the technology we're introducing, the ability of the router is to look at a series of APIs and then automatically, using a routing algorithm, sequence the calls on a bunch of servers on behalf of a client. So it's kind of like a server, but instead of a server where you've written a program, it's a server that's actually using routing technology.
You know, Jacoby, we need a picture.
Allow me.
Go for it.
What I'll do is I'll set some background first. So let's just set the frame. Normally what we have in any infrastructure is applications at the top, and we've got a data network. Of course, this can be really complicated, or it may be simple, it doesn't matter, but there's always applications sitting on top of a network. Now, the complexity is often not in what the app does. Often apps are designed to look really simple. The complexity is more about the transactions that those apps drive. Today, we have a sort of mess in here, which we sometimes call middleware. And if you look at that middleware market, it's valued at something like $25 billion a year. And there are a lot of services, databases, queuing systems, all sorts of systems in there, and they all work in different ways, and they all run different methods, for example, of logging, different methods of handling performance, load balancing, and so on and so forth. Now, the point we're making is that inside there, transactions actually happen. But what is not clear to a lot of businesses is how those transactions happen, and in particular, quite often they're not logged. And it's that logging of what happens which leads to trouble. For example, if you consider, just recently, banks have been fined really enormous sums for failure of their transaction compliance. And I often say that it's not that they're being fined. In the case of Deutsche Bank, and this is public record, they were fined something like 1.3 billion euros for transactions that were not compliant in the US. It's not their apps they're being fined for. It's not that. It's not their network they're being fined for. It's their transactions they're being fined for. And the difficulty is that that's in the middle of a really enormous mess of technology.
Jacoby, let me get this straight. We can put something into the middle here that helps us understand what the transactions are actually doing and allow us to manage and understand those transactions in the infrastructure. But what impact is that going to have on the app developer, and what impact will it happen on the network itself?
Okay, now the transaction router, and I think I'd like to draw it. So if I remove the mess, let's put in a layer here, because we're networking engineers and we like to talk layers. So let's put this transactions layer in here. Now, from the point of the application developer, nothing actually changes. The transaction router still presents an API, which can be REST or it can be SOAP or even Corba, you know, an older kind of API. So the application developer still makes calls on that, but the difference is that the app developer is making a call on a router, not on a server.
This is a question we need to consider. To what extent is this completely transparent to the application developer? Do they know the difference, or is the difference in the behavior and how it's handled transparent to them?
It's entirely transparent. the difference is in here, the difference is not here. So what we're not talking about is changing the way application developers write apps. What we are talking about is a higher level of infrastructure that is able to handle the transactions that those apps drive. The real point is this: if you've got a higher level of abstraction in your infrastructure, then it's much easier to deploy, say, should we say 5 different kinds of apps and have them all use the same infrastructure calls.
Very good. Can we go through an example here to make this a little bit more real? Let's take something that you might have been working on that actually illustrates what's happening under the covers.
Okay, let's just do a bit of drawing. Careful of the unicorn. Now what I'm going to do is put a transaction router here. We're going to use a case which is a ledger transaction. So this is a ledger transaction for a bank. We're going to consider the case that that ledger transaction is a receipt of money, and it updates, say, 3 different ledgers, and it does so in a single transaction. The app makes the call on the router. The router then, using a routing algorithm, not using a program, makes several calls on servers, and then the result is delivered back to the app. Now, when it does this, it automatically provisions services, i.e. they spin up automatically, and the key thing is, using the SDN capability that Cisco One introduces, it provisions paths automatically. So we've got automatic path provisioning. The effect is that we not only do automatic provisioning, but then, and here's the real value add, especially for financial services, we log absolutely everything. So all of these things are logged. That's really big data, and it enables them to audit everything that's occurred.
Brilliant. Love the idea. Thanks so much, and I hope you enjoy the rest of the show.
Thank you.
Oh, we're not done yet.
No, we're not.
No, it's unicorn time.
Oh,
It's time for the unicorn challenge. I think with you guys, you did such a great job. We're going to remove complexity here. We're going to have a simple one unicorn, O&E unicorn time. So let's see, draw a unicorn. Go, go, go. So he's got a model for the unicorn.
I can practice, right?
Well, I think you should commentate while he does this.
Okay. Now, I don't think this unicorn is as unicorn-like as it should be. We've got something that looks like Moominland. This looks like a Tove Jansson unicorn.
Okay, guys, I think you better stick to simplifying technology. Thank you so much. This was fantastic. Really appreciate it. We'll see you next time on Engineers Unplugged.